Hi, you guys. Hope everyone is well. This week's lesson is on solubility and solubility curves. As you can see, the notes look a little bit different. Your notes have some blank spaces where my notes are highlighted. And while I'm going through the video, a good idea would be for you to fill in what the highlighted parts on your notes are. Since we don't have as much work maybe as last week, I thought this would be a good idea to kind of keep you honest with learning about solubility. Solubility is a property, that's a physical property of all substances, and it's a measure of how well one substance dissolves another substance. Usually that substance is water, so solubility is a measure of how well salt dissolves in water as compared to how well, let's say, sugar dissolves in water. And each of those have their own different solubilities. Not all substances will dissolve in the same amount of water, so there's a varying degree of solubility. Fortunately for you and for me and for everyone, nerds already know how much of any substance will dissolve in water. It has been tested many, many times, and there's tables if you pause this and go look for solubility of any substance, you can find it. I don't know why you would do that, but maybe if you want to, you could. So instead of looking at a bunch of individual ones, what will happen is they'll have what we call a solubility curve that shows whatever that amount is. And that's on the last page here. And I made mine super big, so I have to zoom out a little bit. But you're going to want to have this solubility curve either printed out or on your phone. And it's because all the questions that you'll be asked this week on the quiz are going to involve this graph. Okay. So here's how the graph works. Every line in the graph is a different substance. So each line on this graph is a different substance, and they're labeled. And then each line shows how much of that substance can be dissolved in 100 milliliters of water at any given temperature. So if we flip back to the graph here, and I'll zoom back, it says 100 grams of water. 100 grams of water is the same as 100 milliliters of water, so you can either cross that off or just write ml there so you don't forget. I'm immediately regretting crossing it off, so you could just write ml above it, because you'll see problems with both grams or problems with both milliliters. Okay, so what you have to imagine here is that you have like a fake glass of water, and the glass of water is 100 milliliters, and then this is how much of each of these different substances can dissolve in that water at 100 from 0 to 100 degrees Celsius. So it's not like one cup of water and you dump all of these things in there. It's just like one fake cup of water, and you have just, for example, potassium nitrate, KNO3 in it, and this is the line that represents that. There's a few things you can see right off the bat as you look at it. Before I get into that, actually, it's just like reading any graph. So if I said, I better look at my example, at 50 degrees Celsius, so if I go to 50 degrees Celsius here, which is right in the middle, this question says you can dissolve about 85 grams of KNO3 in 100 milliliters of water. So you go up to 50, and then to the KNO3 line, you'll find that the KNO3 line is about at 85 degrees Celsius. Okay. In the next one, it says at 7 degrees Celsius, you can dissolve how many grams of KClO3, and if you go to 70 for the water, and then find the KClO3 line, which is right here, you can see that 70 and KClO3 intersects. Maybe you want to call that like 36 grams. So I wrote 36 grams on my little chart. Nope, on my little chart here. If you take a look at the graph overall, as you increase temperature, most of the solids you can dissolve more of, right? As temperature goes this way, you can see the graph trends up for most of the solids. That's the solid line there. It's exactly opposite, though, for gases. You can see as the gas, you can dissolve more gas in colder temperatures, but for solids, you can dissolve more of them in warmer temperatures. Okay. A solution, there's like kind of three words that go along with this. It's said to be saturated. That's the key word there. Wish I would have highlighted that one instead. Saturated when you have dissolved the maximum amount of solid in it. So if we go back to that last example we did, which was 70 degrees and KClO3, and we said you could dissolve 36. So like right there, that point is what we call saturated for that temperature. So at 70 degrees Celsius, you can dissolve about 36 grams of KClO3 in 100 milliliters of water. That's saturated. Okay, that's the maximum amount of solid. If I tried to dissolve more stuff in there, it wouldn't. It would just float to the bottom. That's what we call saturated. If there are some conditions where you can dissolve more stuff than the graph says is possible. So for example, back to that one, if we were at the 70 and let's say I managed to dissolve, I don't know, what is this, 50 grams of KClO3, okay, even though the graph says I can only dissolve about 36 grams, but like at 70 degrees Celsius, maybe I dissolve 50, that is called supersaturated. So you've dissolved more than the graph says is possible, and that's, I know it sounds super cool. It's not that cool. It just means you've got more stuff in there. It doesn't like turn it into like a super amazing solution or anything. It just is that it has more than this graph says is possible, and there are certain conditions where that works and certain conditions where it doesn't. And then anything less than the line, so if you go back to this line for the 7 degrees, if let's say you dissolved 20 grams of KClO3 in 100 milliliters of water at 70 degrees. Well, you're right here. You're way below the line. That's unsaturated. Unsaturated means you can dissolve more stuff in there. Okay, that's what we call unsaturated. It has room to dissolve more things. So if you're looking at the graph, for any of the lines on the line, that point is called saturated. And anything below the line, whether it's this line or whatever line you're looking at, that's going to be unsaturated. And then anything above the line is going to be saturated, or sorry, supersaturated. So above the line, supersaturated, on the line, saturated, below the line is unsaturated. That's how the solubility curves work. And there's really four kinds of solubility curve questions that you usually see, and you've really already seen one of them. In the first one, it says how many grams of sodium chloride NaCl can dissolve in 100 milliliters of water to make a saturated solution at 40 degrees Celsius. So the way that you solve a problem like that is you go to 40 on your graph. Sorry, there we go. 40 on the graph, and then you go up to find the NaCl line and you see where they intersect. So 40 and NaCl looks like it's about right here, and that to me looks like, I don't know, it's just above 35. You want to call it 36 or 37, that's fine. So I'll call it 37. So 37 grams NaCl. Oopsies, you can't see any of that. There you go. Different kind of question you'll see. How many grams of potassium iodide will dissolve in 200 milliliters of water at 10 degrees Celsius to make a saturated solution? So this question is different because instead of saying 100 milliliters of water like this graph says, 100 milliliters of water right here, this is just for 200 milliliters of water. So instead of reading the graph simply and writing that number down, you're just going to multiply it by 2 because this is for 100 milliliters of water, but the question's asking about 200 milliliters of water. So you say potassium iodide at 10 degrees Celsius. So 10 degrees Celsius, let's find the potassium iodide. Oh, it's way up here. 10 degrees Celsius, potassium iodide, way up top. So follow the 10 up to potassium iodide. And I don't know, what do you want to call that? 135 in 100 milliliters of water. You could dissolve 135 grams of potassium iodide. But in 200 milliliters of water, you'd want to double that. So you just take your 135, which is what our graph said, times 2. Because it's 200 milliliters instead of 100 milliliters. And 135 times 2 is 270 grams of potassium iodide. Okay. Third kind of question you might see. How many grams of potassium nitrate will recrystallize when a solution is cooled? So what happens is if you take a solution and you warm it up and you dissolve some sugar in it, or whatever it happens to be, in this case it's potassium nitrate, when it cools down it can't hold all that sugar that you dissolved in it, right? Because most of these, as you saw, as they cool down they can hold less and less stuff. So what happens is that sugar, or whatever it happens to be, has nowhere to go. In this case it's potassium iodide. So what it does is, potassium nitrate, what it does is it recrystallizes into a solid. Okay, recrystallize means go from being dissolved in solution to back to being a solid. So how many grams will recrystallize when you have it's saturated at 70 and it cools down to 50? So what you do is just find these two numbers and subtract them. So let's see, for KNO3 at 70, okay, here's KNO3 in the middle, And if you follow the 70 up, KNO3 is, I don't know, pretty close. Let's just say for our purposes, let's call it 140. It makes our lives a little bit easier. So if it's saturated at 70, it has 140 grams of KNO3 in it, but it's going to cool down to 50. So let's follow the line down to 50. And at 50, KNO3 has about 85. You can see there at 50, follow it up to KNO3. It looks like it's about 85 grams. So what happens is that's going to turn into a solid then, because it can't hold 140 anymore. It can only hold 85. So the difference is what will be sitting at the bottom then at that point. So all you do is you take 140 minus 85, and you end up with 55. So there'd be a little pile of potassium nitrate at the bottom of that after it cools that would weigh 55 grams. And then finally, maybe the easiest kind of question is the one where it gives you a point on the graph, and you just say, is the solution saturated, unsaturated, or supersaturated? Remember, saturated is on the line, unsaturated is below the line, and then supersaturated is above it. That's important. So we're going to go to 75 grams of sodium nitrate at 30 degrees Celsius. So let's go to 30 degrees Celsius first, and then up to 75, 30 here. Follow it up to 75. So this is the point I'm looking at. And is that point right there, right above where it says HCl, is that point relative to NaNO3? Is it above the NaNO3 line, below it, or on it? And as you can see here, it is well below the NaNO3 line, which means I can dissolve more stuff in that container. And so this would be unsaturated because it's below the line. So there you go, quick crash course on solubility curves and solubility itself. You've got 4 kinds of questions here, and you'll see some of those on the practice worksheet. And that's it, I guess. Like and subscribe. Okay, bye.